Hey everybody, welcome to my YouTube video. Professor Brown has asked me to go over chapter 4.7, and chapter 4.7 is logarithmic scales, so we're going to go and get started. The definition of a logarithmic scale is, well, it's a scale, and on a logarithmic scale, numbers are represented by their logarithms. So what this means is that, like, for certain situations, you might need a much larger scale than just 1 through 10. So, like, say, like, on a number line, usually we would get like 0 in the middle, 10 on the right, and then negative 10 on the left. And like those are small numbers, but like say you need, like say what you're working with goes to like 1,000,000. So you'd have like 0 to 1,000,000 on the right side, 0 to negative 1,000,000 on the left side. You're not going to want to write that out to do the math. That's going to like take forever, and you'll probably make a mistake somewhere. So that's where logarithmic scales come into play, is they make that math a lot easier. And there's 3 major types. There is the pH scale, the Richter scale, and the decibel scale. And we're going to go and start with the pH scale. So the pH scale was proposed by a chemist named Sorensen, and he defined the scale as pH equals minus log, and then like in brackets H plus. I'll go ahead and write that out for you. So it is going to be pH minus, or actually forgot the equal sign, equals minus log, and then in brackets H plus. And yes, there is a base of 10 here, but we don't have to write that because that's like the normal base. And so basically what this is it's the formula for finding pH. So real quick, we're going to go over the parts of that formula. And so the pH, what that stands for is, like, if you have a pH of 7, it's neutral. And then if you have a pH greater than 7, that's acidic. And if you have a pH less than 7, that's basic, and that's like the measurement of like the solution you're using. And then the H plus, that thing that was in brackets, that stands for the concentration of hydrogen ions measured in moles per liter, which you probably won't know what that means, whatever I just said. You probably won't know what that means unless you've taken chemistry before. But that's what that finds, and so we're going to start with an example. Example 1 says, the hydrogen ion concentration of a sample of human blood was measured to be H plus in brackets equals 3.16 times 10 to the negative 8th power m, and it wants us to find the pH and classify the blood as acidic or basic. So for that, basically all you got to do is just plug it into your calculator. You plug the H, because it gives you, I'll show you real quick. So it gives you right here, it gives you H plus and what that equals. So what you're going to do is you're going to plug in your formula into the calculator. So it'll be negative log base 10, because that is the normal base, and then, or the standard base. And then right here is where you plug in your H plus, so 3.16 times 10 to the negative 8th power. And then we're going to hit equal, and it gives you 7.50031, and you'll just round that to 7.5. After rounding that to 7.5, that is what our pH equals. So it asked us to find the pH, and then, which is what we just did, that's what 7.5 is, and then it wants us to classify the blood as acidic or basic. So basically, 7's neutral, and then anything above 7 is basic, and anything below 7 is acidic. So we would put basic, ours would be basic. And yeah, so let's go ahead and move on to example number 2. It says the most acidic rainfall ever measured occurred in Scotland in 1974. And its pH was 2.4, and it wants us to find the hydrogen ion concentration, that's the thing that was in brackets, the H plus that was in brackets. So this time, instead of finding the pHs, which we did in the first example, we will be finding the H plus that's in brackets. And let's go ahead and do that. So to find this right here, we're going to write this equation in exponential form, which will be H plus in brackets equals 10 and then minus pH. And in this problem, it gives us the pH, which was 2.4. So we will do H plus in brackets equals 10 and then minus 2.4. And whenever you put that in your calculator, which I will do right now, 10 to the negative 2.4, it gives us 0.00398, which we can round to 0.004, and that is our answer. So we just went over the pH scale. Now we're going to go over the Richter scale. And so the Richter scale was made by Charles Richter to define the magnitude of an earthquake. And the equation he uses is m equals log and then I over s. I'll show you that real quick. So his equation is m equals log I over s. And real quick, we will go over what these right here mean. So the I in that equation stands for the intensity of the earthquake that is being measured, and then S, which is what's underneath the I when you divide, is the intensity of a standard earthquake, which that is 10 to the negative fourth power. So we'll go ahead and do example 1, which example 1 says, find the magnitude of an earthquake that has an intensity of 3.75. So what we're going to do is we're going to plug in, it gives us the I, which is what the earthquake we're measuring. So we're going to plug that in, and then we already know the standard, so it'll be 10 to the negative 4, so I'll go ahead and show you that. So we are going to take what it gives us and plug that in for I, so we'll have m equals log, and then base 10, we already know that, it's the standard. You don't have to put that. And then the 3.75 over the standard of an earthquake, which is 10 to the negative fourth. And real quick, put that in our calculator. So we have log base of 10, and then 3.75 over 10 to the negative fourth, and that gives us 4.57, which we can round to 4.6. So in our question, it asks us to find the magnitude of an earthquake that has an intensity of 3.75. So that's what we plugged in for I, was the intensity, over the standard of an earthquake, 10 to the negative fourth, we got 4.6. And so that the 4.6 would be the magnitude of an earthquake, of that earthquake that we just did. So we'll go ahead and move on to example number 2. And example number 2 reads, an earthquake was measured to have a magnitude of 5.1 on the Richter scale, and it wants us to find the intensity of the earthquake. So this one we'll be doing it the opposite way. It already gives us the standard, and we will be finding the intensity of that earthquake. So since we want to find the intensity, we are going to take this equation right here, which is our original equation, and put it into exponential form, which will be 10 to the m equals I over 7. And then we'll go ahead and plug in what we know. So we know that S is 10 to the negative fourth. So 10 to the negative fourth. And we're looking for I, so we'll put I there. And then we have 10, and m is what gave us in the equation. It's 5.1, so we'll put that right there. And so to solve this, what we're going to do is multiply here by 10 to the negative fourth, because we're trying to get I by itself, so those would cancel. And you have to, what you do to one side, you have to do the other. So you'll do 10 to the negative fourth on this side. And so what we have is 10 to the negative fourth times 10 to the 5.1 equals I. And real quick, I'll put that in my calculator. So 10 to the negative fourth times 10. Why is it? So since we are looking to find the intensity in this equation, we're going to take our original equation and write it in exponential form, which will be 10 to the m equals I over s. So now that we have that, we will go ahead and plug in what we know. And we know that the s is 10 to the negative fourth because it is the standard of the earthquake. When we're looking for I, so we'll put I there. We have the 10, and then the m is what it gave us in the problem, which is 5.1. And so what we're going to do to solve this is multiply here by 10 to the negative fourth because we have to get I by itself, so those would cancel. And what you do to one side, you have to do the other. So we'd multiply by 10 to the fourth on this, negative fourth on this side. And then, so now what we are left with is 10 to the negative fourth times 10 to the 5.1 equals I. And so, real quick, put this in my calculator. 10 to the negative fourth, and then times 10 to the 5.1, and that'll give us 12.6. So the intensity of the earthquake we're looking for is 12.6. So now that we have gone over the Richter scale, which measures earthquakes, we are going to go over the decibel scale. And this scale measures the intensity of sounds. And so the formula for this is B equals 10 log, and then I over I base 0. And so real quick, we'll go over what each of those variables means. So in this equation, we have B equals 10 log I over I with the base of O. The B stands for the decibel level, and then the I with the base of O is like a reference of intensity, like it's a standard intensity basically for hearing, and then the I is just the intensity of what we are measuring. So real quick, we're going to do an example problem, and this problem reads, find the decibel level of a jet engine at takeoff if the intensity was measured at 100 watts per square meter. So I'll show you what we're going to do. So to solve this problem, we will have B equals 10 log I over I0, base of 0, which is the standard equation. And then we'll plug in what we know, 10 log 10 squared over 10 to the negative 12, which is the standard reference intensity. And then let's put that in our calculator. We will get, so 10 log with a base of 10, and then 10 squared over 10 to the negative 12 should give us, we have 140. So our answer is 140 decibels. So now that we have solved problem 1, which was 140 decibels, we will move on to problem number 2, which reads, it says find the intensity level of a motorcycle engine at full throttle if the decibel level was measured at 90 decibels. So real quick, we will solve that one. So to solve this problem, we will go ahead and write down our original equation. And then to solve this, we will start by dividing by 10. So we'll have B over 10 equals, and then these two 10s cancel. So it'll be log I minus log 10 to the negative 12. And the reason it's this right here is because we already know this part, the 10 to the negative 12. That was the I base 0. And that's what the I base 0 is the standard, the standard reference of sound. And so we'll go ahead and plug that in. And then real quick, we'll go ahead and solve this part right here that I have underlined using our calculator. So it'll be negative log and then 10 to the negative 12. And that gives us 12. So it'll be B over 10 equals the log of I plus 12. And so, oh, I forgot the I. And then we'll subtract by 12 from both sides. Those will cancel. So it'll be B over 10 minus 12 equals the log of I. And in the problem, it said that the decibel level was measured at 90 decibels. So that's what the B is the decibel level. So we'll go ahead and plug that in since we know it. 90 over 10 minus 12 equals the log of I. And so we'll go ahead and put that in the calculator. 90 divided by 10 and then minus 12 is -3. So we get -3 equals the log of I, and since the base of 10 is this, or is the same as the log, it'll be I equals 10 to the -3. So after solving that equation, we got our answer, which is I equals 10 to the -3rd. And so now before I end this video, we're going to do a quick review over what we have learned. We started with the definition of logarithmic scales and proved that definition using all three of the major scales, the first one being the pH scale, where we learned that Sorensen, the chemist, made finding pH more convenient using the formula pH equals -log and then in those brackets H plus. And it's important to remember that H plus is the hydrogen ions, which you'd only know if you've taken chemistry before. And it's also important that with these problems, that once you've plugged it into your calculator and gotten your final answer, that if the problem asks you to, you need to classify whether it is neutral, acidic, or basic. And you do that by, if your final answer was 7, exactly 7, it would be neutral. And then anything above 7 would be basic, and anything below 7 would be acidic. So just make sure you got that plan in your brain. And then secondly, we went over the Richter scale, which is my personal favorite because it teaches you basically how to measure the greatness of an earthquake, which is kind of cool. And the formula for it was M equals log I over S. And it is important to remember that S will always be 10 to the -4th because that is the standard earthquake measurement in centimeters for an earthquake. And then lastly, we went over the decibel scale using the formula B equals 10 log I over I with a base of 0. And for this, you have to remember to plug everything into its right spot and then follow the steps if needed. I'm going to go ahead and do a quick outro. I hope y'all enjoyed this very informational video. Drop a like by hitting that thumbs up button. Comment something down below or subscribe if you feel like it. That button's down there too. And I hope you found this helpful. If not, ask me more questions in the comments or something. But good luck on your finals, and goodbye.